Okay, this session I'm working on PoorMansAnubis. There's some leftover commented out code that I decided to return to. That is making a generic cleanup. This applies to whenever MySQL or MariaDB is being used by this project. Specifically, there are a bunch of lock table statements, and I need to send an unlock table command to MariaDB or MySQL. But the previous way I did this was sending the command before every return point in a function. And a better way to do this would be to handle it when the function ends automatically by using something that goes out of scope. So this is where GenericCleanup comes in, where I give it a function to call once the object goes out of scope or it gets deconstructed. And that function would call unlock tables. And because everything in Rust is destructed in reverse order of initialization, it should work for my purposes here. So first thing I do is work on the GenericCleanup class or struct in Rust. It takes a reference to the data in a function that acts on the data. And by implementing the drop trait for it, I can make it run the function when this GenericCleanup instance is dropped, basically. Well, I'm still doing the, I haven't implemented drop trait yet. I'm implementing the new function to create the GenericCleanup object. Takes a reference, a non-mutable reference, in the function itself, which is usually a closure when I use it. The capital self, uppercase self, is a keyword that references the owning struct in its function definitions in an implementation function. Here I need to add a where clause to specify the bounds and whatever. And finally, I'm implementing the drop trait so that when drop occurs, which is when the instance of that struct becomes deconstructed, goes out of scope, is being cleaned up, it will call the function that it has. I thought fn once would work, but once I set it up in the drop function, it doesn't like it at all. So I changed it to just the regular fn. Fn once takes ownership of the owning function of the function. Just fn by itself takes a reference of the owning function, or in this case, a closure. So now that the compiler is happy with the definition of GenericCleanup, it's time to use it in main. One issue that comes up is I can't use asynchronous function stuff in a drop trait because it's not asynchronous in the drop function. So since I'm using an async mutex for the MySQL MariaDB connection, I switched them all to regular mutexes that are provided by the standard library in Rust instead of the Tokyo provided asynchronous mutex. This changes some things, but thinking about it, these connections are generated on the fly, and they only last for the duration of some functions most of the time. So it's unlikely for there to be a time where mutex blocks because each unique function is making their own connection when it's being called. Of course, this pushes the burden of handling concurrency to the server, but considering it's MySQL or MariaDB, naturally they would be able to handle multiple commands from different clients at the same time. Here is when I actually set up a variable that is an instance of the generic cleanup. Thinking about it now, I could have used the underscore for an elided lifetime parameter for defining the type of the variable. But for now, using it directly equals generic cleanup new is good enough. And then here's the closure. Here's where unlock tables is finally being called. Well, when the variable goes out of scope, that is. And now I have to clean up the rest of the function to not handle clean up unlock tables at every return. Instead, the variable getting cleaned up will handle it now. Well, there are several functions that use unlock tables, so I have to set up the same thing for each of those functions as well. And another function here to handle unlock tables. Another one here as well. And yet another place where unlock tables needs to happen. So it's just about done setting up generic cleanup. So it needs to be tested now. Naturally, because it's using lock tables on a MariaDB or MySQL server, I also need to have it running, the server that is. It's able to handle two things concurrently, but I think I tested more to make sure. For now, clippy fixes. adding some print lines to test that unlock tables is actually happening. And I need to remove the entries from the database so that it could test it again. Otherwise, it would just be allowed because it already authenticated through, well, not authenticated, it solved the challenge and there's a timeout. So instead of waiting for a timeout, I removed the entries directly. So it is definitely using unlock tables. So the next test is probably a concurrent one. And finally, the git commit. This commit has all the generic cleanup stuff. Cross-compile the AArch64 because my Raspberry Pi is running that architecture and that's what my website is hosted on. I'll be testing it on my website to make sure that it works as well. Sending it to my Raspberry Pi here. Placing the binary in the right spot now. First, I'm going to test it on a test server. or test process at least. I guess the server encompasses all of that. So, yeah, we're running a test process first. And the concurrent test worked. So, now I'm going to use it on production. Everything protected by PoorMansAnubis by this process on my website. Now the final test on production. Making sure that, yeah, that particular port is for the test process, so it should be fine leaving it as is. Thank goodness for firewalls, otherwise things would get messed up. The concurrent test, and it passes. No errors. And checking other sites protected by my instance on my URLs, and they all work. So that's basically it. The final things I do is pushing the changes to my Git repositories. So that's basically it. Thanks for watching.